Okay, let's get started then. Hi everyone, my name is Yuan Tang. I'm a principal software engineer at Red Hat, working on our hybrid cloud AI platform.
And I am Eduardo Arango, and I'm a senior engineer at NVIDIA.
Okay, more introduction about myself. I'm on the leadership team for multiple open source projects, including Arango, Kubeflow, and also a chair of Working Group Serving under the Kubernetes community. And I also work a lot on the machine learning frameworks like XGBoost and TensorFlow from my older days. And I did publish a book, Distributed Machine Learning Patterns, if you guys want to check it out as well. And find me on social media. That's my handle over there. So, yeah.
And myself, so I've been working in making containers and cloud-native technologies better for HPC and for 9 years now. So basically, that's my curriculum there, but I just want to go over it very fast. Currently, I work as a co-chair of the Working Group Serving, and I actively participate in projects like Working Group Bash, and also I'm trying to help with the DRA initiatives. Okay, so, but how did the working group got started? So that's a question we got a lot, and it's basically a quick history of KubeCon, right? Like, is the whole success of KubeCon. So during Paris KubeCon, sadly is not here, Clayton Coleman had a quick conversation with Yuan before the on-conference sessions, and then at the on-conference session, we all as a community were already having the idea of, okay, we need a common place to talk about inference and serving for Kubernetes. How do we make this better together? Because at Paris KubeCon, we saw a lot of talks of people trying to propose different ways of solving the same challenges. And although that's good for a conference, moving forward, being disconnected is not good for a community. So everything started at Paris KubeCon, and I'm happy to say that now at the next KubeCon, we are already presenting projects that this working group is leading, even things that we have managed to lead and get into Kubernetes, and it's been only 6 months. So it's been an exciting time for this working group, for sure.
Yeah, it's exciting. Like, one thing to add is Clayton and I also discussed at KubeCon Europe. We talked a lot about some of the solved challenges and pain points from ecosystem projects like Kserve, right? Whether we can bring some of those advancements to the low-level Kubernetes APIs, whether those are the things we can benefit the wider communities. So working group serving is like the best place to host those vendor-neutral advancements.
The second question we get asked a lot is, why is not called working group inference? Why is it called working group serving? And it basically goes down to, we are serving inference models that are already pre-trained, right? So when you mention the word inference, it's basically that you are getting a pre-trained model and you are inferencing based on a prompt to get an output, but you are not serving that model, right? So working group serving goes deeper than just the inference word. We are going over how can we scale out a model? How can we run a model in a Kubernetes cluster in production? How can we get metrics? How can we get alerts? How can we get production-grade inference? And that is actually serving. So it's one of like the top questions that we get here and in other meetings. So we wanted to let it settle here at this talk.
Yeah, and it's not just for AI and machine learning workloads. Like, hopefully, some of the benefits we bring to the community can also benefit traditional workloads like databases and other like web services and so on.
So another question we get is working groups, working groups, working groups. So working groups all the way, right? So at KubeCon Paris, for AI-related topics, the community was at the Kubernetes Working Group Bash, the CNCF Bash Working Group, and the CNCF AI Working Group, right? But the main difference between CNCF working groups and Kubernetes working groups is that at CNCF working groups, you get to talk about things that are not even related to Kubernetes, right? It's cloud overall. We could talk about Apache Spark there, or Apache Airflow, and it's still related to AI and Bash. So at Paris, we had the idea of we needed 2 more working groups to help define what we need for Kubernetes, not CNCF, but Kubernetes specifically, about working group serving and working group device management. So these 2 groups were born out of KubeCon Paris, where we were talking about all the gaps that Kubernetes has towards inference and serving AI models, and this is why we created these groups. And the main difference, the key difference between serving and Bash working group, because people also ask the same, like, is Bash also for the same? Like, you are also running distributed workloads in Bash. You can do inference with Q, which people like get confused. So no, Bash working group is going to be focused on training and on distributed workloads and Bash workloads. And serving working group is going to focus on things like that we will be presenting today, that LLM gateway, DRA, multi-host inference, and we will kind of like hand off like all the Bash-related topics to the working group Bash.
Yeah, so the working group serving is currently led by 4 different companies: Google Cloud, Red Hat, NVIDIA, and ByteDance. But we have more than just those leading companies. We have many participating organizations. We have grown the community to be over 250 community members. So the community is growing really fast. There's a lot of interest in this space, and we invite all of you to participate as well and contribute your ideas.
So why is this working group important? So we have, as is defined in the GitHub webpage that you can find, we have 3 main goals for the working group, right? That hopefully in 2-3 years down the road, we will be able to close the working group saying that these goals have been reached, and we will then have the need to create another working group with a crazier purpose, right? But our goals right now are to enhance Kubernetes workload controllers, meaning we need a better way to control when we deploy LLM models in Kubernetes with projects like Kserve, auto-scaling with projects like KEDA, and we need to get this better because right now there are a lot of challenges. So part of the conversation during the working group meetings is talking with the community, as Yuan pointed, that we have 250 participants in the working group meetings, and we need to find all the gaps when you are deploying these LLM models and try to fix them so we as a community benefit from that. The second goal that we have is investigate orchestration for scalability. And the word investigate is there because as Yuan will be presented later on, we right now have an initiative that is called the benchmarking project, and it's because we are investigating how these LLM models behave in a Kubernetes cluster. What do we need to monitor? What do we need to see if it is running okay or not, right? Like right now, we're kind of like running blind, and mostly because every model is different. Some models, if you track the GPU utilization, then you are kind of like getting the picture, but some models is more like the CPU utilization, the memory utilization, the network bandwidth. So it's like depending on the model, the use case, what you need to track to be able to have good scalable production-ready systems and good auto-scaling is still kind of like being defined, and that's something that we are chatting on the working group meetings. Like weekly, we discuss about a member of the community will join and say like, hey, for my model, if I track this specific metric, everything is okay. So we are taking note, and we want everyone to participate because as it's there, investigate. We're investigating what do we need to know about running LLM models. And the last but not least is optimize resource sharing. And since Paris and before Paris, KubeCon, the fancy word has been DRA. So this optimization of resources goes back to DRA. The working group has a direct communication with the working group device management because we want to make sure that we also leverage DRA for things like multi-node operations and also the better utilization of GPUs. So how is the working group operated? Oh. Oops.
Yeah, so we divide and conquer into different work streams. So the first work stream I'm going to talk about is the orchestration work stream. So what we are doing within that work stream is to identify challenges within those ecosystem projects like Kserve and Ray. So we make sure we understand the challenges and abstractions needed for orchestrating large serving workloads. Understand some of the pain points and use cases from these ecosystem projects. And some relevant sub-projects that we are working on, I'll talk about them in more details, are serving catalog and ORM instance gateway. The second work stream is the multi-node, multi-host work stream. So what we are trying to do is to extract patterns and common practices for running multi-host, multi-node inference workloads. So we talk about different implementations and different ways to achieve cost effectiveness and different ways to optimize capacity and so on. So we are also seeing a lot of increased demand for serving large models on multiple nodes. So larger models don't fit on a single node, and we have to partition and serve them in a multi-node fashion. So Leader Workset is one of the example project we are working on. So it provides some common multi-node deployment patterns for models that are sharded across multiple nodes. And we are also working with ecosystem projects like Kserve to add support for multi-node as well. So the multi-node support for Kserve, the PR for that feature just got merged last week. So if you are one of the adventurous users, feel free to try it out. It's not part of any of the releases yet, but we do want to hear about some early feedback from end users so that we can continue improving going forward.
The third work stream is the auto-scaling work stream. And here is very related to what I was talking about investigating. So like a big chunk of the conversation that are having around auto-scaling are metrics, right? We want to know the best metrics to track for auto-scaling. And we want to be able to work with Kserve and Kata to build a proper production-ready auto-scaling solution. But still, we want to find out the right metrics to track. So that's why we are running these benchmark projects, and we are going to the community to ask, okay, what are you tracking when you are auto-scaling? But it's not just the metrics, right? Another big topic for auto-scaling is these models, as Yuan just mentioned, they are getting bigger and bigger. And then it's not just creating more nodes and adding nodes to your cluster, but it's how do you move the model that is heavy enough now, right? Like hundreds of gigabytes, to the newly created nodes. So are we going to do network attached volumes? Are we going to do image caching? Where are we going with this? So the auto-scaling working group, we are working in initiatives like the OCI volume source that is a topic that years ago, as I was telling Yuan, was called data containers or data images. And it's basically a container that is not a file system on its own, but it's basically just data. And also the model serving metrics, so we need to standardize these concepts. And the last work stream of the working group is the DRA, right? And the whole idea of this work stream is to keep a direct communication with the working group device management. So it's not like the working group serving is directly working on DRA, but we are collecting use cases and feedback for DRA and potentially bugs, and then we are communicating them to the working group device management. Luckily, we have people like John and Sergey that participate in both working groups, so we have that bridge between both working groups, and we help it to push for beta from the working group serving, right? So it's kind of like our responsibility to go and help the other working group to push initiatives and proposals. And right now, we are working with the DRA working group device management to work in multi-host serving and partitioned device support. So we hope to have these features in by 1.34 or 1.33 or 1.34. So that's kind of like the responsibility of this work stream.
Okay, next I'll talk about some of the current initiatives from this working group. So the first one is the LLM instance gateway. So it's currently an Envoy-based tooling to support more like a production-ready and efficient way of serving multiple use cases across a shared pool of hardware accelerators. Those use cases and all LoRa adapters are running on the same foundation model. So we want to make sure the way to share resources is optimal and efficient, and the routing to those LoRa adapters can be like maximized, especially the throughput. And we want to also ensure that there's fairness across those different LLM services with distinct priorities and latency objectives. And we also want to make sure like the configuration for various LoRa adapters and rolling out new adapters can be easy to end users and to allow gradual, safer rollout for new adapters. So this is an architecture diagram for the LLM instance gateway. And on the left-hand side, you can see an example spec for the LLM service. Basically, you can specify the pool of resources and the target models that, with different weights for those different use cases. And we are using extraprog from Envoy to receive and route the traffic to different pool of LoRa adapters and resources, and based on the metrics we've been collecting from, for example, cache size, to determine a more intelligent routing to those LoRa adapters.
So another initiative that we're running, as you can see here, is following through DRA-specific features, and you will find the list. So things that were merged in 1.32, and you will then find it now available for you: the structured parameters, faster scheduling, the removal of the classic DRA, right? So now it's that it went to beta, it kind of like dropped a lot of the things that were proposed on the alpha API, and significant process and auto-scaling integration. So on the chair of the slide that you will find in the Sched platform, you can just click over this and you will get redirected to each specific KEP that was merged for 1.32. And here as well, we are getting NVIDIA DRA driver ready for GPUs. We have the example driver for DRA if you want to build your own DRA driver for your own specific needs. Google, the TPU driver is in process that I think it will be ready for next KubeCon, the CNI DRA driver. So all of these initiatives are in progress, and we from the working group serving are tracking them to see how can we help them, how can we help get the KEPs pushed forward so they get included in the next Kubernetes release. Missed but on track for the next release are also a couple of KEPs that we are helping to review and also push forward so they get included in the next Kubernetes release. And as I said, there are many more to come, right? Like at the working group serving and also the working group device management, there are a lot of topics being discussed on what can we add to DRA so we make it better and we can run more complex workloads. The other topic, as I was mentioning before, is something that I don't know if I'm old enough or everyone here is old as me, but I think at DockerCon or KubeCon like 2018 or 19, people were already talking about data containers, right? Like that was kind of like a topic that people were mentioning, and now it's becoming relevant. And it's becoming relevant for model caching. These models are so big that we need to find ways to move them around our Kubernetes clusters, and we found out that leveraging on what we already have with the image spec, that is the layers, we could move data around with these layers, right? And Docker, Podman, Cryo, all of them already know how to pull and push layers. And when we have a big container, our runtimes already know how to do also parallel pulling. So we want to leverage all of these features that we already have in container runtimes and move LLM models around, and that's the OCI artifact initiative that we are running.
I just want to quickly mention that Kserve also supports our model car feature, which also streamlines the process to pull models directly from OCI image registry, and which could enable more efficient auto-scaling. So that's currently a hacky solution, but we do plan to make sure the transition to OCI volume source is smooth. So as long as you are using model car now, I think there will be a very simple toggle to turn on the experimental feature for OCI volume source as well.
Next one is you.
Next, I want to talk about the serving catalog. So this is one of the projects the serving working group is working on. So we want to make sure we have a place to provide working examples for different popular model servers like VLM, or open models like Llama, Mistral, and so on. And also provide examples for different deployment patterns like single host or multi-host inference. And we also want to make sure like people can find all those different primitives and orchestration frameworks within the same catalog as well. As part of the exercise of building this catalog, we are also exploring the common configurations and patterns for inference workloads so that we can understand what are the things we need to abstract going forward, and whether we can provide some really common parameters so that the community can based on and tweak from there. And we are also supporting multiple runtimes, as I mentioned earlier. We currently support VLM and JetStream and several different models, but more model servers and model support are coming up soon. And there are also contributions on auto-scaling for HPA configurations as well. And we're also adding additional templates for multi-host inference to this catalog. The next initiative is the benchmarking tool we recently just started working on. So the current state is different companies have the different tools to benchmark their large language performance, either for different model server runtimes or different models, or different use cases. Are you using LoRa or not? Everything are very specific to internal use cases. So we set together with different communities and companies who are building these similar benchmarking tools. We gathered the use cases and requirements together. So what we are working on now is a more standardized benchmarking tool that can be used as a library that support multiple different model servers, and it's hardware agnostic and simple deploy, especially on Kubernetes. So we can use this standardized benchmarking tool to solve different benchmarking needs like auto-scaling or LoRa use cases, especially with the instance benchmarking the instance gateway using this new tool that we are coming up. So I won't get into the details here, but we have a proposal coming up, which we'll be sharing with the community soon. So we invite everybody to join the community meeting if you'd like to hear more details about this new project. I'd also like to talk about some of the involvement with the ecosystem project. One thing I have in mind is the Kserve project. So we are working on, as you might have heard, we are working on the AI Gateway project in Kserve. That's a collaborative effort between Bloomberg and Envoy communities. And we want to make sure we are aligned with the LM instance gateway as well. So going forward, we'll try to figure out a way to work together and integrate well with each other. And we're also contributing to the serving catalog to make sure we provide enough examples to the communities, the Kserve examples to the community, so that the community members can explore those patterns and starting point, can use those as a starting point for their production-ready serving workloads. And we'd also like to leverage the benchmarking tool we are working on, and As part of this collaboration with the working group serving, we did identify some of the gaps. As you can see from the right-hand side, there's a table of differences between the blueprint proposal that was shared with the working group serving community and Kserve. We identified the missing parts in Kserve, and we take active actions to implement and try to fill that gap. For example, the multi-host feature that we recently added to Kserve is one of the big frequently requested feature from the community. So we also published our roadmap in Kserve in case you want to know more about what we are working on and planning to work on. Not every tasks items are already assigned yet. So if you are interested in contributing, join one of the Kserve community meetings, and we'll figure out how to get you started contributing. And we do have a lot of talks at KubeCon. This is just a list of example talks we already had, given this is Friday. A lot of the talks were given, I think all of them, I guess.
Yeah, but this talk will also be recorded, so in case you missed one of these, just look up these names in YouTube, and you can watch the recording in case you miss it.
So make sure, if you're interested in Kserve, there are specific talks related to that. There's also a very popular panel from the Kserve community that showcases how we collaborate with each other, with the communities and industry partners. And there are also call-outs in different sessions as well. How do we get involved? You can find the charter information under Kubernetes community repo. We have Slack channel on Kubernetes Slack workspace. And feel free to reach out to one of the co-chairs and sub-project leads. And some of them are also attending the talk, so I see a few over there. So feel free to stick around and hang out with us after the session.
Special thanks to Ray, who couldn't make it, and help us with the slides as well. So Sergey, also a working group chair, is here.
And Ashok is also there working on the benchmarking and metric standardization.
Thank you, everyone, for helping us. It was Yuan and myself, but this is a joint effort as we are pointing in names, but KubeCon only allows 2 at the stage. But thank you, everyone.
Thank you. Do we have time for some Q&A?
Do we have time for 1 or 2 questions?
Yeah, we do have time. So, any questions? There's a mic in the center if you are. Okay.
Hey, I'm Alex, and I'm actually really happy that I came here. So it's perfectly big now lead in terms of work. So one thing I saw is there was, of course...
Excuse me, do you mind speaking closely?
There was this big announcement about SMG Glue, the AI gateway from Solo, coming in. And then, of course, Kserve has the inference gateway. Is there any connection between these two right now, or this is going to be figured out over time?
There are some overlap, and we are trying to make sure we leverage whatever effort is already there, so to avoid any duplicating effort. So as I mentioned in one of my slides, we'll be working more closely together between the two, between working group and Kserve community. So we'll try to figure out a plan forward as well. If you have any specific feedback, feel free to join our meetings, and we are very open to suggestions.
Thank you. Preparing for this talk, I was also discussing with Yuan that part of the working group effort is to avoid duplication, so we can focus in single ideas and work together as a community. So this is kind of part of our job, right? See if there is someone out there proposing something, and we are already working on that idea, so we just invite them to the working group.
Great talk, thank you. I guess I'm curious about, with fractions now, and Carpenter doing things like bin packing, is there any connection between these things? I mean, putting workloads across nodes that have got a lot of GPUs on them. Any thought to bin packing?
So that would be into the working group and the workstream orchestration, right?
Yeah.
Where does Carpenter fit into all of this, I guess? That's the work group cluster, isn't it?
Yeah, if you have
Cluster
any.
scaling?
Yeah, I don't have anything on top of my mind, but if you have specific questions, feel free to join our course, and we can discuss with the community. So.
Yeah, I mean, I can imagine a whole bunch of inference servers that are, I mean, this is the IBM use case they were talking about as well. You know, a whole bunch of inference servers that are smaller than a single node, and you want to bin pack them, right?
Okay.
We have a lot of scenarios. It depends on what the server is and how you want to bin pack. Do you want to partition by time, like MDS, or you want to partition by size and like try to make it smaller. Like the LLM instance gateway, for instance, it's very different from other gateways because it has use cases inside the model. So you have one foundational model, multiple use cases, and now they're sharing GPU among themselves. It's an easy way to share, and it's very powerful. But what we're talking about, maybe different models, like without like common foundational model, and this will be different use case. And to implement that, we need first, to implement it with Kubernetes, we need Kubernetes to support it better. That's why we're doing DRA right now.
Yeah, that's part of it, right? I mean, you can create a fraction and bin pack on it.
Things like preemption of workload.
This is mine.
Workload less important, you can preempt it, like request is more important workload. Or you want to scatter multiple pods with even MPS and try to do time slice. And it's all on the roadmap. Our focus right now is DRA specifically. So make it do beta, get adoption, and then start with the features.
Good stuff.
Thank you.
So let me do a quick survey. Who's not in working group serving yet? Who hasn't got involved yet? Okay. Good to know. Yeah. So we invite you all to join, like to share anything specific questions and use cases. It's an open community. So, yeah.
Thank you, everyone. No more questions.